Pump math. Part 1. All we're trying to do is get water from the pump to the nozzle, right? So why do we need math? The main idea is to figure out what to do with the pump to overcome physics to get water out the nozzle. And we're going to work backwards, from the water coming out of the nozzle back to the pump. So let's talk nozzles. This is a smooth bore. You can see it has a smooth bore. You can see right through it. Cool. This is a combination or fog nozzle. You can't see through it at all. If you look into it through the water intake side, you can see there's all kinds of stuff in there. So basically the water comes through, you can adjust this, and it sprays in different patterns. Because this one is doing more work, it needs more energy, or more pressure in this case. It says right on it that it wants 100 psi, pounds per square inch. These guys don't do as much work, they just shoot the water through, narrow it down, keep it a good flow. These normally work at 50 psi. You can see it with your garden hose. If you don't have enough pressure, it doesn't do what you want it to do. So we need to do something at the pump to make sure this gets 50 psi or this gets 100 psi. To get the right pressure to the nozzle, we have to overcome 3 forces. The first is gravity. This is about the height of my spigot. If I raise it up, it's fighting gravity, turns into a dribble. If our nozzle is higher than the pump output, we need extra pressure to do the work to fight gravity. And that's called elevation loss. On the other hand, if the nozzle is lower than the pump, then you win. That's less pressure you need to provide because gravity is working in your favor. And that's called elevation gain. So you gain when it goes down, but you lose when it goes up. It's kind of backwards, but it makes sense. The second force is friction loss. Friction loss is the energy or pressure that you lose as water flows through the hose itself, and it's different based on the size of the hose. Think about it like drinking through a different size straw. Drinking through a tiny straw takes a lot of energy, and you don't get that much water. Drinking through a bigger straw takes less energy, and you can get it more quickly. The third is appliance loss. It only applies in high flow situations. And basically, we're just accounting for the energy we lose when the water's flowing fast through things that change the direction of the water. So that's the idea. We're going to learn how to calculate elevation pressure, friction loss in the hose, and account for appliance loss. And we go through all these calculations to figure out how to set the pump to get the right pressure to the nozzle. But don't let all of this scare you. Most departments have pump charts because they've got predetermined hose lays they use so they can reference the chart very quickly, get to the settings they need. That being said, it's always good to know the theory behind them.